Welcome to video lecture. Myself Ashwini Apke, Assistant Professor, Department of Civil Engineering. Today we are going to see about the stresses in rigid pavement. The different types of stresses developed in the cement concrete pavements are wheel load stresses caused by heavy wheel loads, wrapping stresses caused by temperature differential between the top and the bottom of the pavement. It is possible to determine the stresses developed due to the wheel loads, wrapping of contraction of CC slab, and is not possible to estimate the magnitude of stresses as a result of volumetric changes in the subgrade. Wheel load stress. The Westergaard gave the theoretical formula to determine the stresses caused due to the wheel load applying on the rigid pavement. For this, he carried out the following assumptions on the rigid pavement. The cement concrete slab is homogeneous. It is a plastic plate. The subgrade reaction being the vertical or proportional to the reflection. The Westergaard's equation for the stresses due to the wheel load applied at three critical locations of interior, edge or corner as given below. So you can see the formulas of the stresses in the interior loading, edge loading and the corner loading. The maximum stress produced by a leaf at the corner does not exist around the load, but it occurs at some distance as x along the diagram. This distance x from the corner is given by the relation x is equal to 2.58 root of AL. Here the A represents the radius of wheel load distribution in centimeter and the L represents the radius of relative stiffness in centimeter. The radius of relative stiffness. The Westergaard defined the radius of relative stiffness I, which is expressed by the equation I is equal to AH cube by 12K into 1 minus mu square the whole power 1 by 4. Equivalent radius of the resisting section is given by B is equal to root of 1.6 A square plus H square minus 0.675 H, where the B represents the equivalent radius of the resisting section and A represents the radius of wheel load distribution in centimeter and H represents the slab thickness in centimeter. Temperature stresses. The two types of temperature stresses are produced due to the temperature variation in the concrete pavement, that is wrapping stresses and the frictional stresses. The wrapping stress due to the temperature differential between the top and the bottom of the pavement as a result of daily variation in the temperature at the location, and the frictional stresses due to overall increase or decrease in the temperature of the pavement slab as a result of seasonal variation in the temperature at the location. Wrapping stresses at the interior, edge and the corner formulas are being given. Frictional structures which have been calculated using the formula SF is equal to WLCF whole divided by 2 into 10 power 4. The design life should be estimated if the stress ratios exceeding 0.44 due to the higher loadings are noted and the fatigue analysis to be carried out on the number of repetitions during the design life. If assumed thickness is failed, the next trial is made for suitably revised thickness. The total of the edge load stress due to heaviest load and the edge wrapping stress on the summer mid is calculated. The total thickness is less, the fractional strength CC, the edge is accepted, otherwise the thickness is further revised until the highest possible total stress value does not exceed the flexible